This exercise on surds is asking, with the help of factor pairs, simplify the square root of 12. Let's consider the square root of 12, and I'm going to consider the number under the root, which is 12, and I'm going to find the factor pairs of 12. Now these are essentially two numbers that when multiplied together will give you 12, and we've covered this elsewhere on this channel. So I know 1 times 12 is 12, I know 2 times 6 is 12, and also 3 times 4 is 12. Now you consider all of the factors shown up by these factor pairs, and you'll ask a simple question: are there any of these numbers that are a square of another number? And the answer is, in this case, that we've got 4. 4 can be created by 2 squared. I'm now going to take the factor pair that contains the 2 squared, and I'm going to bring it to the top of this slide together with the square root of 12. Now I can write the 3 times the 4 as 4 times 3. I've just effectively swapped them round, because 3 times 4 is 12 and 4 times 3 is 12. So we can see that 4 times 3 is equally as valid as 3 times 4. Now it'll become obvious why I've put it 4 times 3 in a moment. What I can do now, I can say that the square root of 12 will equal, and you'll notice here I've put in the root, under the root, 4 times 3, which I've taken from here. Because 4 times 3 is the same as 12, because 4 times 3 gives us 12. I am now going to apply a general rule. So if I now want to go further, the square root of 12, well, I can make that equal to, and you take the square root of 4, and note by itself, it independently under a root sign. You then bring down the multiplication sign, which you can see is not under a root, and then the 3, well, that's put under its own root, and this is valid. In other words, if you were to multiply the 4 by the 3 and then take the square root of the result, you'll get the same result as this, where you take the square root of 4 and separately take the square root of 3 and multiply both those answers together. This will give you the same number as this here. Now you may want to prove that to yourself, but this is a general rule that I will be introducing you to in a moment. I can now continue on to say that the square root of 12 equals 2 times the square root of 3. Now this 2 has come from the fact that I've taken the square root of 4. Obviously this multiplication sign comes down, and you can see that the square root of 3 still remains here as the square root of 3, because this is a surd. There is no point me writing this in a decimal form, because you cannot write it down accurately. Now it's usual to write this out as follows: the square root of 12 equals 2 square root of 3. In other words, you can see here I've removed this, because if there is no sign between this 2 and this root, it implies it's a multiplication. Let's consider the general rule that I've used in this video. You will recall that the calculation you see is something that was used earlier in this video. Now what it meant was, here you can see I've got 4 times 3 under a root, and I was able to split that up to the square root of 4 multiplied, and the multiplication is not under a root, the square root of 3. Let's now look at the general rule that I've used for the calculation you can see. And that general rule is shown here. If you have two numbers multiplied together under a root, then you're allowed to do this. You can say, take the square root of those numbers separately and then multiply them together. Now I can present this general rule as follows. You have AB under the root sign, and the AB means that the A is multiplying the B. And then you can say that this is the same as the square root of a multiplied by the square root of b. And of course, we can write this as you see here, the square root of a, the square root of b, with no multiplication sign in between. But what this means is you take the square root of a first, then the square root of b, and with the results of both of those square roots, you multiply them together. So this is the general rule, and if you're going to work with surds, you really need to learn this general rule and use it when you're dealing with surds.